Welcome to my Facebook page and my YouTube channel. Today we continue looking at integration by parts using the DI method. Last time we looked at the type 1 in which we were differentiating until we get to 0 on the differentiating side. Now today we are looking at the other type, the type 2. So let's look at how we can integrate e power x sine x dx. So remember we said we should choose which one can easily be integrated and which one can easily be differentiated. So on the D part, that is the differentiating part, we pick which one can easily be differentiated. On the I part, integration. So we know that e power x can easily be integrated and sine x can easily be differentiated. So let's get started. Don't forget to alternate the signs. Plus, minus, plus, minus. Okay, so we put plus, minus, and so on. Okay, so we said we differentiate sine x and integrate e to the power x. Okay, so what do we get when we differentiate sine? We get cos x. Got cos x. When we differentiate cos, we get negative sine x. When we differentiate negative sine, we get negative cos x. Then when we keep integrating, we still have e all the way e power x. Okay, so according to the DI method, last time we said you have to diagonally multiply these numbers. Okay, so let's observe what will happen. Okay, so we have sine x times e to the power x. That is e to the power x times sine x. Then we have negative cos times e power x. That gives us minus e to the power x cos x. Now, if you look at this one here, we note that the function in the equation has repeated itself. So when that happens, you multiply these two functions that have repeated, because remember, when we multiply this sine x times e to the power x, the result is the integration. So when we multiply, whichever you multiply, sine x times e power x, the answer is integral of sine x times e to the power x. When you multiply cos x times e to the power x, the result is the integral of e power x cos x. So when we observe a function repeating itself, in this case, the first one is e power x, then sine x. Then when you look at this, it has also repeated the same. We have sine and also e. So when you reach such a stage, you multiply them. And remember, I've said when you multiply, you get an integral. Okay, so let's continue. So at this stage, we multiply. So we are going to get a minus because of this positive here and the negative. So we are going to get a minus integral of e power x sine x dx there. So we observe that this function is the same function as this one. So when that happens, we end and just multiply the row that gives us the repeated function in the question. Okay, so this is what we get. So we can now copy all of this. Okay, so we say the integral of e to the power x sine x dx in a question should give us, copy all of this, e to the power x sine x minus e to the power x cos x, then minus this integral e power x sine x. Okay, so we can say there, since we have the same things here and there, the other is negative as we can see, and the other is positive here. What do? We introduce the additive inverse to both sides. Or we can make this negative integral this side to cross to the other side and join this one. When that happens, the negative integral becomes positive on the other side. So let's try to move. Okay, so we have the integral of e power x sine x. We bring this one with a sign, it becomes positive this side. The integral of e power x sine x dx is equal to this now. So we have e power x sine x minus e to the power x cos x. Okay, here we are. So we know that these are like terms, we can add them. So when we add the integral of e to the power x sine x plus the integral of e power x sine x, the answer is actually 2 integral of e to the power x sine x, which will give us e power x sine x minus e power x cos x. Wonderful, we are getting somewhere. Okay, so we can easily divide both sides by 2, or we divide each term by 2. These 2 goes away. Then we have the result, half of e to the power x sine x minus half of e to the power x cos x, of course, plus c. So let me just write this one down here properly. So the result is half of e to the power x sine x minus half e to the power x cos x plus c. That will be our result. Okay, so it's pretty easy. So if you so wish, you can factorize or just end here. But if you wish to do more work, and that is if you still have time during exams, you can factorize. You say half e power x, or you multiply, you say e power x over 2, then you open brackets, then there you remain with sine x, there you remain with cos remain with cos x brackets then plus c. When we do that, we are done. Okay, so what are we saying? In this type, when you see the function repeating itself, you end there and just multiply the repeated functions, which is sine x here and e to the power x, which is equivalent to e power x here and the sine x. When you reach such a stage, you multiply. When you multiply, you get an integral. Then you just correct the right terms and finish your integration. Thank you for watching. I said we have 3 types, so look out for type 3, which will be coming out soon. And always remember to subscribe if you have not yet subscribed, and share this video with your friends who are interested or students of mathematics. Until next time, I love you.